So the next thing in our notes, it's what the problem is asking. We're on the top of page number 11, and that would be grams to grams. Now, what we're going to do is just add another thing to the middle part of the table or the picket fence, and it's not that hard. It's no different. We're still going to follow the process, and we won't go astray. Sound good? All right, so the first thing you always need to do is what? Balance. So will you balance that problem if you have not already done so? This is just on the top of page 11. All right, and whenever you do grams, I really, really want you to start at the start and then go as far as you can and then go to the end and then go backwards until you meet in the middle. If you'll follow this process every time, you should be fine. All right, so here we go. We've balanced this reaction literally 5 to 10 times. So if you see a 3 and a 2, what do? Swap-a-roo. 2 in front of the 3, 3 in front of the 2. That makes 4. So it's 4, 3, 2. Who had that right? Raise your hands. Okay, we're getting better at balancing. Some of you, I just saw some frustrated faces. I don't know. We've been doing it a while. Yeah, I would be frustrated too if I didn't get it yet. Come in as much as you can for help. All right, this problem is going to have 3 of these vertical lines. And I'll show you how to know that, how you would know that eventually. So here we go. It says how many grams of AL? So just right off the bat, look right here. It gave me grams of AL. Now, it already gave me that. So let's look together and learn what that fills in. Are we ready? Since that's the first thing it gave me, I might as well start filling in. What do I know about this part then? All right, the unit at the end is the unit at the end. Grams of AL. Now, anytime I have grams, it's per what? 1 mole of the same thing. Now look. I guess I'll have to wait and then you can look. Okay, good. Please make sure this makes sense. If all of you are okay that the unit there goes there, which I think everyone's okay, then look, is everyone okay that the unit here must go there? It's the same thing. It's a two-way street. All right, so up here, I'm going to get rid of some of this stuff. Where is it? It's under that thing, so I can't. Oh, well. All right, so up here we have mole AL. Do I know what goes here? I don't yet. All right, so I'm not going to worry about it. All right, that's as far as I can get so far. So I'm going to keep reading the problem. How many grams of aluminum were used to make 79 grams of aluminum oxide? So now I have the other piece it gave me, and it's 79 grams of Al2O3. All right, now that will give me some information on what goes down here. Does anyone know what that is? What unit? The grams of Al2O3. Then tell your lab partner, anytime you find the grams on the periodic table, it's per what? Tell your lab partner right now. Good. 1 mole of the same thing. So 1 mole of Al2O3. If I know this unit, what do I know? I know the bottom of the next. Mole Al2O3. And now the picket fence is completely filled in. I can start at the start, I can start at the end, and I can always meet in the middle. So now I do have to fill in some numbers, correct? The easiest numbers come from the balanced chemical equation. So what is in front of the Al? A 4. What's in front of Al2O3? A 2. But now I got to do math. I need to find the mass of Al2O3. So we're going to use our periodic tables. The big number for aluminum is 27. But there are 2 of them because of that number. and we're going to add, there are 3 oxygens, and each oxygen, the big number for O is 16. You type that in your calculator, and it's around 100, isn't it? What did you say? 102? All right, so that's 102, and we know that's grams per 1 mole, which we already put, the 1 mole, so we put the 102 right here. And then the last spot I'd have to fill is just the grams of Al, which we found right here, was 27. And now I have a pretty ugly picket fence, but we can do it. If I were you, the first thing I would do would be to reduce anything I could reduce, because that'll save me some calculator steps. So if you notice, 4 over 2 is really 2 over 1, right? So now you would take 79, multiply it by 2, multiply it by 27, and then divide that answer by 102. Will you all type that in? If you need a calculator, there's one over here in this box. Anybody need a calculator? Yeah. Anybody else need a calculator? I'll have to. Thank you for trying. Okay, type that in and double check you get the same answer as your lab partner. Okay, it's not. What is this one? 41.8. Who agrees? I do. All right, good. All right. Kind of all right. We start grams on one side, we start grams on the other, and we fill our picket fence in until we meet. All right, we're going to do one more practice problem before we do any of the homework. There's a little space on the bottom of page 10. If you can, put it there. If you can't, just put it somewhere. I don't really care. But try this problem. It says, how many grams of oxygen would be consumed if we burned 580 grams of propane? This is a combustion reaction. If you're stuck on the balancing, but you get the math, I can come give you the balancing answers. Well, I'll just put them up here in like 2 minutes. All right, let's work through this together. I didn't see a lot of successful answers here. So, this is oh, hold on. How many grams of oxygen would be consumed if we burned 580 grams of propane? We can start at the start or the end. I already wrote this, so I'll start at the start this time. So if we have 580 grams of C3H8, what do I know about the unit at the bottom? It has to be the same grams, right? So grams of C3H8. Anytime I find the molar mass or the mass in the periodic table, it's per what? 1 mole of the same thing. 1 mole C3H8. What do I know about that unit then? It's that unit. Mole C3H8. All right, then there's nothing yet that tells me what to go here. So when I get stuck, I got to go to the back. So it's asking for grams of O2. I saw 3 people that put grams of O. You have to have grams of O2. It will matter quite a bit. All right, so we come over here, and that means the unit here is grams of O2. Whenever I find grams in the picket fence, it's per what? 1 mole of the same thing. If this unit is down here, it means it's the unit up there. So I have mole of O2 right here. And then I'm ready to get some numbers. So the easy ones, once again, typically the easy ones come from up here. There's a 10 in front of the O2. There is a 2 in front of C3H8. When I walked around, some people had already reduced this to 5 over 1. Is that okay? Yeah, it's fine. All right, now, grams of C3H8. So we have 3 carbons, and each one of them weighs 12, plus 8 hydrogens, and each one of those is 1. So we have 36 plus 8, which is 44 grams per mole. We have the grams. There's the mole. All right, then oxygen. This is why this matters that it's O2. Oxygen is 32 grams per mole, not just 16, because it's O2. All right, and then you would type 580 times 5 times 32. And then you would divide that answer by 44. Anyone have that? 2109. Anyone back that number up? Okay, that's a lot. 2109. All right. There's your grams of oxygen. How many had that right once again? Okay. Tricky, but doable. All right. The rest of them are the ones from the homework. Number 43. I will help you with this one eventually, but will you try it on your own first? So magnesium carbonate, when heated, decomposes to form magnesium oxide and carbon dioxide. How many grams of this? So we're asking for grams of MgO. That's our question. Will be formed if you have 20 grams of that. See if you can do that completely on your own, and I'll work it through in a couple minutes. What's the answer? Somebody? Packer, what do you have? 9.5? Raise your hands if you have 9.5. Okay, so the people raising their hand don't need to pay attention to me, but everyone else must need to. All right, so here we go. We're just going to try to repeat everything we've been doing over and over. So we take the number and the unit given. So 20 grams of magnesium carbonate. All right, how many grams of magnesium oxide? So whatever, this is our given. So we take the unit of the given, grams of MgCO3. And anytime we write grams, it's per 1 mole of the same thing. Then, anytime we have a unit on the top, it becomes the bottom unit of the next one over. So it's mole MgCO3. But that's when I get stuck. So now I go to the end and I work my way backwards. The problem is asking how many grams of magnesium oxide will be formed. So grams of MgO. Then the unit at the end is always the unit at the end of your picket fence. MgO, grams. Anytime I write grams in the picket fence, it's always per 1 mole of that same thing. And then the unit at the bottom is always the unit to the top left. So I know this is mole, MgO. And then I plug in the values. The balancing was easy. It already was balanced. So we'll put these in blue. There's 1 and 1. So math-wise, that step's pointless. Chemistry-wise, that step is super important because that's where you go from what you were given to what you want. All right, then I just have to find the mass here. Magnesium is 24 from the periodic table, plus there's 1 C, that's 12, plus there are 3 oxygens, that's 16. So 48, 60, is this 84? 84 grams. When you do all that math, it was 84. And then magnesium oxide is just 40 because it's 24 plus 16. And then I'm ready to do the math. 20 times 40 divided by 84. And if I remember right, they said 9.5 is our answer. Okay, if you didn't have that, write it down. And then, number 44, let me help you with the chemistry. Gold 3 chloride decomposes. So, the only thing it can do is break into both of its elements, right? So, AuCl3. Decomposes, so you have to cut it in half. Au plus Cl, but Cl is what? Diatomic. You have a 3-2 swap. 3, 2, 2. There's the chemistry. Will you try and do the picket fence now? Now, I'll warn you right now, gold 3 chloride is probably pretty heavy. Does anyone have that number already? Did anyone find what the mass of this is? 303? Okay, that'll save you some time. You do have to find that number for your picket fence. Okay, you do the rest. All right. Let's do this problem. What is it? What's the given? All right. 60 or 16? 60. Okay. So 60 grams of AuCl3. I'm just going to go fast. Grams AuCl3. This unit and that unit always match. Grams is always per 1 mole of that thing. Then whatever unit's here always goes here. What am I solving for? Is it grams of gold? This is so fat. All right, that means this is grams of Au. Anytime it's grams, it's per 1 mole of that same thing, meaning these always have to match. And that unit goes up there. Mole, Au. I come here, I find a 2. We'll put these in red. 2 here. AuCl3 is also a 2. So those can reduce to just 1 over 1. And then we gave you that number. I think Moyle told us 303.5. Is that right? That was the right number. And then 198, 199, 197. And then we do math. 60 times 197 divided by 303.5. As I walked around, was it 38 something? All right, so we'll just call it 39. How many had 39? Raise your hands and keep them up for a minute. Okay, that's like 95% of you. Okay, the next problem, chemistry-wise, was that. Take a few minutes and work on that. Hopefully you were able to get 15. And I'm not introducing the next step, which is, I don't know, easier actually. We actually go backwards to make it easier, then make it, I don't know. There's nothing that's any harder once you learn this process. But I want you to look right here. If you will all take your periodic tables out and find this. It's on the side you've been looking for your numbers. All right. This is our actual map that we can use when we do stoichiometry. Now, I always teach it without it, and then we come back and show you that it can be useful. So the first thing I need you to do on this is we're going to draw a vertical line right here that just goes right through the middle. And that line is there because you always have to cross that line in order to be done with these problems. Now, you might have to keep going, but you always have to cross it. What this map shows you is if you know what you're given and you know what you want to find, it will tell you the steps to take to get there. So if you will look real quick, today we've been going from the given of grams to the unknown of grams. To get there, we followed a three-step process. We went from grams to moles, then we used the ratio of coefficient to go to moles, and then we used the picket fence to go back to grams. There are 3 arrows in between grams and grams. Can you see those? Those arrows are what will tell you how many vertical lines you need in your picket fence every time. They'll actually tell you what they are too, if you need them. I don't, like, that makes sense, and I think the process I use makes sense. I think it's easier to do it my way, but those will tell you. And if you look, we were using the gram formula mass, or we were using moles per gram in the first step. Then the second step was always mole over mole. Do you see that? Then the third step was always gram over mole. If you'll look back real quick, when we first did it, we went moles to moles, and there was one step, so there was one vertical line. I've still got 15 seconds. Then the second set we did, we went moles to grams. There were 2 arrows, or 2 vertical lines. Tomorrow, if you'll look, we're going to go from here to there, or from here, there to there. And I'm out of time. Okay.